Hello again. Thank you for joining us on the Space Nuts podcast, episode 245. I'm your host, Andrew Dunkley, and with me again, as always, is Professor Fred Watson, Astronomer-at-Large. Hello, Fred.
Hi, Andrew. How are you doing? Good to see you. Especially now it's stopped raining.
I'm well, sir. Yes, at last. We've had about a week's worth of it, and we got triple our monthly average for this part of the world, but we didn't get the flooding that has been happening in many other parts of New South Wales and Queensland, and it's been pretty hectic, and people are still trying to deal with it. Thousands have been evacuated, and we've seen houses floating down rivers and cars being washed off causeways. Why people insist on driving through floodwaters, I do not understand. You're better off being late than late, if you know what I mean. And I was saying on air on the radio this morning that these last 12 months have been extraordinary. It's like the apocalypse. We've had severe drought, fires, then COVID-19, then we had rain, then we had floods. We've got a mouse plague, a rat plague. We've got a slug plague, I found out. We've got locusts. There's just so much going on. I can't wait to see the movie. It's just, it's just crazy times. Crazy times. And I feel for all those people who are going through the flood situation. There's nothing more dire than that. But it just adds another insult to what's been a pretty horrendous 12 months. I think it's almost exactly a year since we went into lockdown in Australia. And so many other countries are still in lockdown. What horrifies me, Fred, is there's so many people still trapped overseas because they can't get home, and it's nearly a year. I mean, this is just unbelievable. But you're not in a flood area of Sydney, are you? You've kind of in a more hilly part of the city.
Yeah, we live on a ridge 200 metres above sea level, so if we get flooded, Sydney's gone.
Yeah, very much so. Anyway, we just keep our fingers crossed that all is well now. The floodwaters will just do what they do rather slowly, but we will start to see things get back to normal soon, I hope. That was what we pray for indeed. So, Fred, we've got an interesting show today because it is entirely created by the Space Nuts audience. Everything we do today is based on audience feedback and questions. We've got a little bit of feedback to deal with, and we'll do that. We've also got a whole bunch of questions, so we might as well just get straight into it, Fred. And our first question is it's a text question from Peter in South Australia. My question is about dark matter and dark energy and the speed of light. We often hear about how old the universe is and how far away things are. The two are often measured and modelled in computer situations. I'm curious to know how you factor in dark matter. We hear it comes in clumps, and I'm curious to know what you put into a computer model to allow for dark matter and dark energy. Do we know what effect dark matter has on the speed of light, or how light reacts with dark matter? It boggles my mind to know astronomers and physicists get space travel and distances so right without really knowing what dark matter or dark energy is. Or does the effect of this dark matter and dark energy only happen when you get out of the local galaxy cluster? Thank you, Peter. It's a good question, and one that's probably got a few people wondering, I imagine, Fred.
Yeah, great stuff, Peter. And in a way, I think the last part of the question sums up what's going on. Does the effect of this dark matter and dark energy only happen when we get out of our local galaxy cluster? To some extent, that's when we start seeing their effects. The interaction of light with dark matter is zero, effectively, because photons and dark matter particles, whatever they are, they don't talk to each other. And we know that because there is no dark matter doesn't reveal itself by anything that is to do with light. For example, you can't see dark matter silhouetted against bright nebulae and things of that sort in the background. It doesn't block our view, so it doesn't actually interact with light at all. The only way we know it's there is by its gravitational effect. So there is perhaps one thing to add to this, though, and that's the sort of big picture stuff. The people who look at the universe as a whole, both now and 380,000 years after the Big Bang, which is when we can see back as far as in the cosmic microwave background radiation, both the universe today, in the sense of the distribution of galaxies, where they're placed, how they string out along these filaments of the cosmic web, that plus what we call the power spectrum of the cosmic microwave background radiation, which basically means how clumpy it is in terms of these slight temperature variations that we see looking back to the flash of the Big Bang. So those are two yardsticks, the universe today, the universe back then, and they both tell us something about the gravitational influence of stuff, and that includes both the stuff we can see and the stuff we can't see. So when you do the analysis of this, you actually get these values out for what the total amount of dark energy is, which is something like 70% of the mass energy budget of the universe, total amount of dark matter, which is about 25% of the mass energy budget of the universe, and what the rest is, and that's about 5%. These are very broad numbers. So that breakdown comes out of just the distribution of matter in the universe, and that's why we can actually make these claims is the wrong word, but give estimates of what these total mass values are. As I said, though, dark matter doesn't interact with with light. In fact, it doesn't actually interact with anything except gravity. So all the other fundamental forces are not affected by dark matter, and dark energy is a property of the universe as a whole. And so that the dark matter, the photons of light and radiation pass through the universe without being affected by dark energy. It's really the matter distribution that tells you about the way these two phenomena act on the larger scale. I haven't really made that very clear, I don't think, but it is. It's the way it is. And just returning again to what I said at the beginning, Peter's last question: do the dark matter and dark energy, or do their effect only happen when we get out of our local galaxy cluster? To some extent, that's true, because it's only when you start looking on very large scales, certainly in terms of dark energy, that you see its effect. Dark matter, we have to look at galaxies as a whole. There is evidence that dark matter might come in clumps no smaller than about 1,000 light years across. And so anything within that is not going to see its effect, because it's effectively uniform throughout that. Throwing in a couple of added aspects. So that's I think the answer to Peter's question. I hope it works.
Yeah, me too. But I think we've talked before about the naming of these things creating some confusion with people. So, people hearing the words dark matter and dark energy may well get a misrepresentation in their minds as to what this actually is. Is that one of the issues?
I think it is. Yeah, I absolutely agree. It's a rubbish name. I think they're both. Invisible matter would be a much better name for dark matter. Dark energy I can kind of get, because it's something you can't see, and maybe that should be invisible as well. Of course,
yeah,
and I didn't say, but they're revealed by dark matter is revealed by its effect on galaxies. They shouldn't behave the way they do if it wasn't there, and dark energy is what tells us that the universe, or what we think is the reason for the universe expanding ever more rapidly, the accelerated expansion of the universe.
Yeah. One day maybe Fred will figure this out, but it's sort of starting to become one of those great mysteries. Well, it already is a great mystery, but one that just keeps bringing up more and more questions and curiosity. And like black holes, we're starting to get more and more questions about these two things as we do for black holes, because they're so very mysterious as well. So it seems like anything dark or black in colour in the universe is causing us a few headaches. Anyway, Peter, hopefully we filled in something of a blank for you. We can't obviously give you absolute answers when it comes to these strange and mysterious things in the universe, but appreciate your question. Thank you so much. Let's move on to our next question. This one comes from Ralph. No, it doesn't. Yes, it does. It comes from Ralph in Northern California.
Greetings, Chief Nuts. I have a question for you regarding the theory of relativity. This is Ralph in Northern California. Since the speed of light is finite and constant, can it be said that the theory of relativity is well illustrated by comparison of the relative distances you are from a light source? In other words, the position in space of a light source, say 3 meters from my pupils, will be far more real-time than a duplicate light source 3 light years away, which will be in a different position in space by the time the light reaches my pupils than it was when the photons began their journey. And that same light source only 300 meters from my pupils would be the tiniest amount less real-time than 3 meters, and so on. It's all relative to perceived locations based on travel time, or time travel, of photons. Relative real time of the receiver versus actual real time of the emitter, or something like that. Anyway, thanks for the great shows. Keep it up, and can't wait for Perseverance to hit Mars.
Thank you, Ralph. Obviously, this question came in before Perseverance landed, and we're glad to be able to report, Ralph, it did land and everything is okay, and it's even moved. And I do believe, Fred, they're just about ready to test the helicopter, so it's just getting super exciting on Mars.
Next big step, that's right. Okay.
Yes, indeed.
Well,
but
ahead.
To Ralph's question.
Yeah, okay. Ralph's question. Yeah, actually, the point that Ralph makes is a very good one, and it's excuse me, one of the reasons why in the very early phases of Einstein putting together his special theory of relativity is one of the reasons why he did. And what Ralph is talking about is the notion of simultaneity, whether things that happen simultaneously in the universe happen simultaneously everywhere. And that actually was certainly one of the things that went into the thinking on the special theory of relativity. The Newtonian universe, the old-fashioned universe, says that if something happens in the universe, everybody sees it simultaneously. But for exactly the reason that Ralph has mentioned, the finite speed of light, that's not the way it works. Simultaneity it doesn't really have a definition in a relativistic universe, because your perception of two events is going to depend on how far away each event is. So if something, a supernova explodes at the same time in two widely separated parts of the universe, and you're near one and far away from the other, you're going to see the near one first. For all extent, for all purposes, for all practical purposes, the timing of an event is actually the timing that you see it, rather than the time when it really happened in some sort of absolute sense, because that's the only way the information can come to us. Nothing can come to us faster than the speed of light. So you see one supernova going off, and then 40 years later you see another one going off, because it's taken 40 more years for the light to travel. They might have been simultaneous in the sort of absolute. If you could look at the universe from the outside, they might have been simultaneous, but they're not in terms of our perception of them. And our perception is the only thing we've got. Yep. Or what?
Or the first one could have been the second one to explode. I mean, in terms of proximity.
Yeah. Yes, the order. And that brings into effect, to consideration, all kinds of things like causality and what causes something to happen, and cause and effect being in the right order, which actually some modern theories of the reality of the universe, they dispense with the idea of causality. I think Stephen Hawking was working on one of those. Anyway, what Ralph has said is a very nice summary of the fact that things are not quite the way we think in the world of relativity.
Indeed, yeah. I saw a news story today, actually. It was in the popular press, which is my nice way of saying that the headline sells the story and then the truth is very boring. But this one said, "Star explodes." And I thought, okay, that's either Hollywood or astronomy. And I thought, and they were talking about a nova. And I thought, and someone was in the studio with me at the time. I said, check this out. They've said a star has just exploded. My bet is it's happened billions of years ago. And sure enough, the headline was designed to get you in because they made it out that this star exploded yesterday. What actually happened was, yes, we've got remnant light from a supernova going back billions of years, which is not sexy enough to sell a headline. So, yes, it's all relative, Fred.
It's relative, that's right. Yeah, as always.
All right. Okay, thank you, Ralph, for your question. Appreciate hearing your voice too. It's great to get these audio questions in, and we've got a bunch more to come here on the Space Nuts podcast. Stick around.
Roger, you're loud and clear here also.
Space Nuts.
This is the Space Nuts podcast with Andrew Dunkley and Professor Fred Watson. Just want to shout out to our patrons, growing in number steadily. Thank you for your financial support of the Space Nuts podcast. We appreciate that you enjoy it enough to put a couple of dollars a month into the kitty to keep us going. Our Patreon numbers, we're aiming to get 500. We've got 113 patrons in there now. You can also join Supercast if that's your preference, or you can log on to our website and click on the Support Space Nuts button and see what options there are. You can do one-off donations through whatever platform you choose. I can't remember the name of it right now, but it's in there. You can also donate through our distribution platform called Acast. Now, this is purely voluntary. I'm not going to make you do this. We're not going to force you to do it. It's an option. But if you are doing it or you're thinking about doing it, that's fabulous. We really do appreciate it. We do want to ultimately make the podcast 100% listener supported. So that's the goal. And ultimately, we'd like to get up to 1,000 patrons. And you can start from as little as $4.50 a month if you want to become a patron of the Space Nuts podcast. And we've got some ideas on rewarding our patrons, which we'll tell you about a little down the track. Not only with bonus material, but other options. So, Fred, let's move on to our next question. This one is a repeat questioner, but I love how he puts the full stop on his questions. It's Roger the truck driver.
Hi there, Space Nuts. My name is Roger. I'm a truck driver. I've called in before. Tonight I'm traveling across New York State here in a little bit of a snowstorm. I was listening to the show where you were talking about binary stars, and I had a couple of questions. When I was young, I had someone point out the second star in on the handle of the Big Dipper. Was told that it was a binary system. Was also told it was the astronomer's eye test, whereas if you could see that faint star with the naked eye, then you had pretty decent vision. And I made a note of the positions of those two stars, and thinking over time I would watch the movement of them. And here it's been some 45 years, and they don't seem to have moved. So at this point, I'm assuming that they're very far apart, or is it really a binary system? And is it possible that you could have multiple stars instead of just two in a system where it would almost resemble a solar system, multiple smaller stars orbiting a larger one, or if anything like that's ever been seen? Anyway, still digging the show. You guys keep up the good work.
I love that. Drive safe, please. And thanks for the question, Roger. Binary stars, as we've discussed, are not uncommon, but when you get beyond that into systems of three or more, it starts to become a fair bit more rare. But yeah, let's firstly go back to the system he was talking about that he looked at 40 odd years ago. You were nodding your head, so you're obviously aware of what he's talking about.
Absolutely. In fact, Roger's mentioned one of my favourite stars, Alcor. which is we from the latitude of New South Wales don't see the Plough, or the Big Dipper, as I think it's called in the US. It's part of the constellation of Ursa Major, the Great Bear. If you're up in Queensland, you see it, if I remember rightly, in May night, very low down on the northern horizon. But it's a northern hemisphere constellation. But one of the stars, the middle star of the handle of the Plough, has this companion. So the stars of the Plough are really quite bright. They're definitely naked eye stars, but they're a bit like the Southern Cross down here. They're spectacularly bright stars, particularly when you look at them through binoculars. But right next to this middle star in the handle of the Plough, which is called Mizar or Mizar, is this little companion called Alcor. And Roger is right that Alcor is thought to be gravitationally bound to Mizar, because they're at the same distance away, and as they move through space, and remember we've got the Gaia spacecraft, which is exquisitely precise in telling us about the way stars move through space, as they move through space they move together. And so even though the 40 years that Roger's talking about is not long enough to see Alcor's position change with respect to Mizar, it's probably going to take thousands of years to see any difference. But the thinking is that these two are actually bound together gravitationally, which makes them a binary system. But in fact, it's more than a binary system, and this goes to the second part of Roger's question, because Alcor itself has a companion, which was discovered back in 2009. It is not that faint, actually. It's ninth magnitude. It probably wasn't detected earlier because it's quite close in, and it's a red dwarf star, which are the commonest stars in our neighbourhood. So that is also it's also co-moving with the Mizar system. So it is, and in fact I think there are more, because Mizar itself I think is a quadruple system. So you've basically got 6 stars which are in a sort of cosmic dance. They are multiple stars, and they're all orbiting a common sense of gravity. It's what is sometimes known as a stellar sextuplet. That's basically what it is. So okay. Roger's observation is great. As I said, every time I go to the northern hemisphere, which used to be quite regularly but seems to have stopped, if I've got a clear night, I always have a look for Alcor. Sadly I can only see it through binoculars now. It's, as Roger said, it's a good eye test if you can see it with the naked eye. It's 12 minutes away from Mizar. I need binoculars these days to see it, but it's always nice to see. So thanks for that question, yes. Roger, I really appreciated it.
Yeah, so he's right. There are systems out there that are made up of stars that resemble solar systems, but rather than planets, you've got stars orbiting each other in clusters.
Yeah, that's right. And in fact, you can understand why that would be, because we think stars form in much bigger groups. We think we call them open clusters. These are newly born stars. Sometimes there are thousands of stars in open clusters, and eventually they dissipate, they drift away. The Sun was almost certainly part of something like that. The Sun might have had a binary companion, or even 2 or 3 companions, which are now long gone. So it's easy to understand why there should be these multiple systems.
Okay. Thank you very much for your question, Roger. It's time for a change of accent as we go from binary stars to the Starshot mission.
Hello, my name's Duncan from Weymouth, Dorset in England. Long-term listener to the podcast, really enjoy it and I hope you both are well. With regards to the Starshot mission to Alpha Centauri, I was just considering that we don't know the star system's layout that well, how many planets are in it in entirety, or where they actually are in their orbits and all the rest of it. And if we got hundreds, thousands even of microscopic spacecraft of just a few grams each hurtling towards them at 20% speed of light, what impact would they have if all of a sudden there are, 10, 20, 100 of these things flying down through the atmosphere of a planet? Would they reach the surface? Would they burn up? I mean, given that things hit the Earth all the time, but they're not going at 20% the speed of light. So I just wondered, we're shooting these things off at a planet that, for all we know, might be occupied, even if not by an advanced civilization. Would it have any impact? Anyway, thanks very much. Bye.
Thank you, Duncan. Yeah, he brings up an interesting point about us kind of invading another solar system and perhaps dropping a bundle on an occupied planet. Not something you want to do, and at that speed, I dare say an object that small would burn up. But I suppose it depends on the planet, depends on the atmospheric conditions. It might not have an atmosphere at all, and we just go ploughing into it and knock someone's block off. I mean, yeah, but and you and I have talked before about us sort of infecting other worlds and some of the things that are being done to try and alleviate that problem. But here we are sending stuff off into the never never and hoping we miss certain things.
Well, let's let me backtrack a bit to say what what exactly it is we're talking about here. Duncan's right. There is a project. It's not a mission. It's a project called Breakthrough Starshot, and it's a feasibility study rather than an intent to actually do anything, although you never know, it might happen one day. But the feasibility study is about the possibility of sending, exactly as as Duncan has said, tiny spacecraft weighing just a few grams, just a few centimetres across, equipped with pretty well nothing but a camera and a transmitter, which are blown along by laser light. So they've got light sails, and you accelerate them using high-powered lasers, which don't exist yet, to 20% of the speed of light, and that means it takes you 20-ish years or so to get to the nearest star system, which is the Alpha Centauri system, and Proxima is the nearest star. We know that Proxima has at least one planet, possibly Earth-like. It may even have more than that. So it's a really interesting idea, the project. The other thing that Duncan mentioned was that the plan would be to launch these things in very large numbers, thousands of them, and you just blast them all along with these high-powered lasers. Now, exactly as he says, we've no idea of the layout of the Proxima Centauri system. The odds are that if you did this, supposing it all happened, we blasted off 10,000 of these things towards that star system. The odds are that most of them, and probably all of them with numbers like that, would miss hitting anything because space is so big. And it's, at that speed, if they are travelling at 20% of the speed of light, they're not going to be captured gravitationally by the star or its planets. They're just going to keep on going. So they'll head off into the wide blue yonder and probably go for a very long time. They'd be a bit like Oumuamua coming through our solar system, which came from somewhere else and flashed through and then keep on going. It would be very much like that. However, to get to the nub of the matter, supposing one did have a direct hit on a planet, what saves you is its mass. Its mass is so tiny that even at that speed, and suppose there's an atmosphere there, it would flash into non-existence. In a split second. It might reach the ground, but at that speed it would vaporize essentially as soon as it hit anything solid. It could be, if that solid was somebody's head, it might not be all that impressive, but the likelihood is it would never hit anything. But it's a really it's a really interesting conjecture. We're very familiar in the world of asteroid impacts with what the effects of asteroid impacts are, but they're only going at a few tens of kilometers per second at most. When you get to thousands and tens of thousands of kilometers per second, then you're in a different ball game. And but the energy goes up because it's kinetic energy is half mv squared. The velocity is squared. So as soon as you get up to these high velocities, it's carrying much more energy. But as soon as it hits something solid, because it's so small, it's going to vaporize. It would almost certainly vaporize as soon as it hits the atmosphere. Great question, though, and lovely thing to conjecture about too.
I'm hopeful that this is a mission that gets the green light and that they do it. I think even though the results and the information will be a long way down the track and probably beyond our lifetimes in terms of any feedback or footage or whatever it is they're going to gather, but I'd just love to be able to say we are going to send a mission to another star system and send back data. I think that's the next giant leap, isn't it, Fred?
Well, it is. That's right. It is a long way away. I think what's interesting is what we were talking about the other day, getting free samples from other star systems coming in, like Oumuamua. If we can mount a space mission to go and collect something, the next time something like that goes through, then we've got a treasure trove of information.
We sure have, yeah. Thank you for the question, Duncan. Oh, and while we're talking about Oumuamua, it's in the news again because, to my great disappointment, it is not a space doogie, it's a space cowpad, as it turns out. They think it's a sliver of a Pluto-like planet that's been worn down by its travels and turned into just, I think they described it like a piece of soap, and as you use the soap, it just becomes that, I think they described it as that annoying sliver, and that's what Oumuamua seems to be, just a sliver of a piece of a planet.
Yeah,
it is
smaller than we thought.
So that's the latest news.
So only something like few kilometers, a few meters across, rather than being tens of meters, which we thought before, and that's because they think it's shiny. It's a really interesting piece of work. It's cast new light on Oumuamua. It seems to explain all the properties that we saw, and so that might be drawing a line under your space doobie,
Yes, oh dear. I think I'll still call it that just for fun. I was deadly serious before, but now it's just going to be for fun. Now let's move on to a bonus question. This one's got nothing at all to do with astronomy. So what's it about?
Hello, this is Andrea from Worcester, Massachusetts. I've enjoyed listening to your show, and I often feel like in the background I hear birds or a bird. Is it a pet? I guess I was just wondering, could you introduce us to the third host of your podcast? Thanks.
Well, we do have Gregory Peck, the rooster, but I suspect that's not what you're referring to. Fred and I both live in areas that have a vast number of birds. I don't have a pet bird. I used to. I used to have budgerigars when I was younger, and we used to let them fly around the house and crap on everything. But they no longer. So there's no birds living in my house. What about yours, Fred?
No, there aren't. I mean, there are the chooks, the hens and the rooster, exactly as you've said, Gregory Peck. There is a bird that I think we're its pet, actually, rather than the other way around. This is a pure white peacock, which took up residence some time ago and comes and goes. His name's Bianco. He just kind of wanders around. And he has a very unattractive call, which is a kind of honk. So it's not that Andrea's talking about. And you just mentioned bird, let me call it bird poo, a minute or two ago. Most birds, they're nothing compared with a peacock. You have to treat it as an obstruction in the road. It's monumental. Anyway, this is descending into different territory. I think what Andrea's hearing are the birds. I often record, as I am doing now, with the door open. We live in a fairly rural area, even though it's Sydney, and often birdsong comes through the door. And some Australian birds have the most awful calls. The cockatoos, I think we've talked about before.
The screeching.
Yeah, they screech, but a lot of them have got the most exquisite bird calls. The most remarkable one is the butcher bird, which sounds exactly like somebody whistling. It's an
last week
song.
we had 4 butcher birds at work last week, and they were doing that beautiful call. That they have one of the most extraordinary calls I've ever heard.
It is.
And,
it's very human.
Yeah, very, very, very beautiful. Yeah, if you can get online and have a listen to the butcher birds, you'll be amazed at the sounds they make. Birds that I have in my backyard that make some beautiful sounds are the little wrens, the blue wrens. I've got a couple of families of them because I've got my house surrounded by shrubbery, and that's perfect for them because it gives them good cover from predators. And they just jump around the backyard and them make that kind of sound all the time, and they're talking to each other, and fantastic. Yeah, I've become so good at doing the sound of a blue wren. I can hear them and go up to the hedge and stick my face in and make the sound, and they come up to my face to see what this intruder is. They don't realise it's me, a human being, but I confuse the hell out of them. They must be very, very miffed. But one day I was doing it, and the blue wren, the big leader of the pack, ruffled up his feathers as if to say, I'm going to get you whoever you are, wherever you are, you're in my territory. Beautiful birds. So little blue wrens. We get magpies here. They warble beautifully. Peewees, corellas, cockatoos, pink and grey galahs, they're screechers as well. We got some beautiful bird life around here, as you do too, Fred.
Indeed. And one I just heard actually a few minutes ago here is one that you don't have there because it's coastal, and that's the whipbird.
Yes.
I don't know whether you heard
I heard that.
That's it.
They
exactly
make that incredible whip. Yeah. And the other bird that people overseas might want to listen to when they go scrounging around the internet to listen to some of the bird life we've been talking about, the bellbirds. Now, they generally live in the tops of mountains, but they just make these beautiful chimes, I suppose you'd call them. They're incredible. And they're a tiny little thing. They're so tiny, and they make that amazing sound. So in answer to your question, no. Only chooks at Fred's place, but neither of us have birds. But you said you record with the door open. When I'm on air at the radio station, I go live with the front door of the station open and the studio door open because I like to hear the sounds from outside, and I don't care if they go to air with the microphone open. Sometimes I'll ask people to honk the horn because that it just adds to the show. I don't understand this philosophy of sitting in a silent room. It just doesn't make any sense to me, but I think I'm in the minority when it comes to radio. But yes, thank you very much, Andrea, for your question. Yes, you do hear rightly. There are birds in the background quite often while we record the podcast. You're listening to Space Nuts, episode 245 with Andrew Dunkley and Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Thanks for joining us on the Space Nuts podcast. Andrew Dunkley here with Fred Watson. And hello to all our Facebook followers, especially those on the podcast group, the Space Nuts Astronomy Science podcast group on Facebook. It's a growing community. Lots of people get on there and talk to each other about what's happening in astronomy and space science. They ask each other questions. Some people ask the questions there rather than bringing them to us. Sometimes they do both. It's a great place to go to just sort of get to talk to each other as Space Nuts followers. And I'm sure some friendships have been struck during that process. So check it out. It's called the Space Nuts Podcast group on Facebook. It's the listener-generated Facebook page, if you like. There is an official Space Nuts page that you can also follow. Why not follow both? And you can stay in touch with us that way. We post a lot of material as it happens, so you can always be up to date. And you can also sign up to our astronomy newsletter on the website, spacenutspodcast.com. Now, Fred, let's get back into the questions. And this one comes from Michael, I think.
Hi there, this is Michael from Oregon in the United States. My mother's Australian, so what's up, y'all? Just wanted to ask a question. You probably already answered this question, but the Earth moves at 1,000 miles per hour, and the ISS travels at a much faster rate. And I'm just curious how that works, how it just continually goes so fast, and why that and how that happens. Love your podcast. You guys are awesome. Have a good day. Thanks.
Thank you, Michael. I picked the accent. Knew he was an Aussie straight up. No worries.
Good on you.
We'll have to teach you a few Australianisms, Michael, so that you feel more at home. And our best to your mother. ISS, the speed of orbit. We know about the speed of getting into orbit that's required to get out of the gravitational pull of Earth, and well, you don't really get out of it. You just stay fast enough not to fall back into it. But the speed of orbit, that's an interesting question, because you do have to be going lickety-split out there to move around the planet.
Yeah, so Michael's got he postulated that the Earth moves at 1,000 miles per hour, but actually it doesn't. It's much higher than that. We normally think of it in kilometres per second, that the Earth moves around the Sun at 30 kilometres per second. It translates to almost 70,000 miles per hour. I did the calculation there just to put it in those units. So that's the first thing. The Earth is moving very fast. So the International Space Station is travelling much more slowly than that. It's about nearly 8 kilometres per second, which is roughly 18,000 miles per hour. So it's all about, exactly as Andrew has just said, it's all about gravity. So the Earth is gravitationally bound to the Sun. It's performing this fine balance between its motion and the gravitational pull of the Sun. Its motion around in orbit is what stops it falling into the Sun. Likewise, the International Space Station is doing the same thing, but around the Earth, but more slowly. So if you had something travelling at 30 kilometres per second, the speed of the Earth, if you had something travelling at that speed, it would not be in orbit around the Earth. It'd be heading away from Earth. It's higher than the escape velocity, which is 11 kilometres per second. So it does all work well.
Right.
Every time you've got some body in space, it has gravity and it can hold things to it, either sitting on the surface as we do, or in orbit, moving around it.
Simple. Really?
I thought you were about to say something, so that's why I stopped talking.
No, I never say anything, Fred. You know me.
Okay. Yeah,
I'd never butt in. I'd never do anything like that.
The strong silent type. Anyway, I hope that helps. And say hi to your mum from us.
Yes, indeed. Thanks, Michael. Appreciate the question. Let's move on now. This question comes in two parts. There was a technical problem with the recording of this question from Misty West in Western Pennsylvania. I noticed Misty also reacted to a post we put on the Space Nuts podcast group on Facebook about the mouse plague here. There's a famous photo that's doing the rounds on the internet of somebody who's scooped about 200 or 300 mice out of their swimming pool and took a photo of the catch. Yes, that's quite commonplace. I can tell you some horrifying stories of what's been happening around our way, Misty, and everybody else if you're interested. One family that my wife served in her shop last week said they had to move out of their house on a property outside of Dubbo on a farm because they were being woken at night by the mice nibbling their fingers and toes. Horrifying. So they're going to wait it out in town in a flat. We caught two mice in the radio station the other day, Fred, and we caught them in a live trap, so they didn't get their necks snapped. The funny thing is I walked into the studio and I saw one mouse in this cage because it's a one-way cage. They can't get out once they get in. They enjoy Christmas cake, as it turns out. When I walked out of the studio and then went back in, there were two. So What's transpired since then is we were a bit slow to deal with them, and one decided, I'm going to murder the other one and eat it. And so that's what happened. So, yeah, it's not fun. It's not fun. Another friend of mine who is living on a property is catching 200 a day. He's got all sorts of traps around his house. He's trying different models to see what works best. The one that he finds works best is a bottle shoved into a tub with a bait at the tip of the neck of the bottle. And what they do is they walk out over the bottle, and when they get to the thin part, they fall off into the bucket. He's caught 200 a night doing that. It's just incredible. But yes, Misty's reacted to that post on the Space Nuts podcast group, because we talked about the mouse plague last week, and Hugh decided that we should give you an example of what's going on. But to Misty's question, please sit back, relax, go and make a cup of tea or coffee, because this is going to take a while.
Hi, Andrew and Fred. This is Misty West from rural western Pennsylvania. I love your show, and I wanted to say that I really enjoy the personal side of some of the episodes, like hearing about the local town names and history, the cool birds we hear in the background, Fred's cats, or the crazy plagues that you can keep in Australia. I have two questions that they don't seem related, but they do have to do with the biotic evolution of the universe. And all the discussion about the universe expanding has me thinking that we're very lucky to be alive while we are. So won't far future civilizations not see other galaxies the way we can? And will they only see their own local galaxy, or maybe just a few gravitationally bound galaxies to theirs? Or will the universe end before that happens? And could far previous civilizations observe more galaxies and maybe less black holes or neutron stars or planetary systems or other middle-age universe wonders? So that's all one question. My second question is that made me wonder a lot about how our civilization evolved to perceive the world around us. And it seems like we observe everything as a wave function or a collapsing wave function or something like that. And I know we've discovered a lot by greatly expanding detectors of the electromagnetic spectrum, but so it detects all kinds of things we can't even see. But are we looking for other things that aren't, anywhere on the spectrum, like not a wave? I tried reading about particle detectors, and it does seem like all the ways that we have to measure things involve looking for a wave. So is it possible there are things in the universe, such as dark matter, dark energy, that don't have a wave function? I hope this isn't just a fundamental question that I completely missed in high school, but I don't see any articles about it anywhere, at least ones that I can understand. Thanks a lot. I love your podcast, and learning about the universe never gets old. Thanks a lot. Bye-bye.
Very true. Thank you, Misty. I don't know what high school you went to, but they never asked me questions like that. It was pretty dumb, really. But, I would have loved to have gone to a high school that asked those deep and dark and meaningful questions about life, the universe and everything. Now, where do you want to start, Fred? Biotic evolution, what future civilizations we'll see compared to what we can see now?
Indeed, that's a good place to start. And Misty used a term that I like very much, the middle-aged universe wonders. Because I guess we are in a middle-aged universe. It's 13.8 billion years old. That means there has been time for stars to form, galaxies to form, planets to form, and the elements to come into existence that come in the interiors of stars, and sometimes there are explosions, those elements that make our world such a rich place, and in fact which allow life to be created, because there were certainly not the raw materials of life at the beginning of the universe. However, its future is a little bit on the bleak side, because at the moment our best understanding of the expansion of the universe is that it's accelerating due to this mysterious stuff called dark energy. And so as the universe accelerates, the time will come exactly as Misty postulates, that you will only be able to see down the track, and this is a long, long way, we're talking tens of billions of years, but down the track, you will only be able to see the galaxies in your immediate neighbourhood, and for us that means us and Andromeda, more or less, probably the Triangulum galaxy as well, and a few dwarf galaxies. In other words, what we call the local group, because everything else, the universe has expanded and carried it so far away that the light will never reach us coming from those other galaxies. So it gets to be a rather lonely place, and it may well be that if there were civilizations at that phase in the universe, they really might not be able to see all that much in the sky. They'll see the stars of their own galaxy, but really, nothing beyond. When we think of what we can see by looking into the depths of the universe, we see this richness of galaxies and quasars and other things, and it makes for an extraordinary, phenomenon, if I can put it that way. I do apologise.
Yeah.
There's a helicopter taking off not very far from here. I think I know who it belongs to, because this might not mean anything to anybody outside Australia, but Dick Smith lives across the road from us, Andrew.
Oh, does he?
Yes,
wow.
And he has a helicopter, so he's a very well known aviator. Yeah, so he's just, I think that's him leaving.
Yes, he made his fortune in, Dick's a self-made multi-millionaire, made his fortune in electronics, and sold off his franchise, and now he's trying to do philanthropic work about buying Australian products and keeping the money in Australia, etc., etc. Yeah, he's quite a big voice in the media these days. Yeah, as he always has been, really.
And he has a noisy helicopter. I hope it didn't interfere too much with the audio there, but it's gone now. Anyway, that's slightly off the track. But yes, so it's remarkable that we are where we are and when we are, and there are all kinds of things that you can draw from this. I am not optimistic about finding intelligent life anywhere else in the universe because of various realities in terms of the way we seem to have evolved. And so in some ways, perhaps we are a product of a middle-aged, wonderful universe. Really interesting thoughts, which I don't have time to talk about now. Let's go on to the second bit about wave functions, and I think just going to the point that I think Misty talks about wave functions and thinks about is in the context of dark matter and dark energy, and it's true that. Well, let's take dark matter first. We believe it's some kind of subatomic particle. All the subatomic particles we know about exist in this quantum world where it's a combination of a particle or a wave, very strange notion, which means that everything has its own wave function, which gives it this probability that it can be in different places at the same time. It seems very likely that whatever it is, dark matter will behave the same way. So we might have wave functions. It's still possible, I think, that dark matter could need other dimensions in which to exist, and that opens a whole other can of worms. But we might have wave functions that cross dimensions. That would be an extraordinary thing. Dark energy, the same. If it turns out that dark energy is carried by some subatomic particle in the same way as we think gravity is, even though we haven't got a quantum theory of gravity, then that too would have a wave function. But that's straying into territory that I really know nothing about at all. Would like to read up on it, but I'm not surprised, Misty, that you've not been able to find anything written about this, because these are quite esoteric concepts, but good thinking. It's very interesting stuff, and the more time goes on, the more we'll learn. Especially when we discover what dark matter is. I think that will be a big turning point in our understanding of some of these really deep realities. What a place to end the podcast in these biggest questions that we can possibly ask.
Yes, and look, she brings up one very good point. There are probably lots of things out there yet to be discovered, things we have no way of detecting. Absolutely, definitely, yes to that. And we're starting to see that, like in my lifetime, how much have they discovered that we didn't know existed back in the 60s? I mean, and there will be more. There will definitely be more. And we will certainly be keeping our ear to the ground in regard to that. Now, one more thing, and thank you, Misty, for your questions. One more thing, just before we finish, Fred, we have a correction that needs to be broadcast. This one comes from Mary Jo.
Hi, my name is Mary Jo. I'm coming from Tucson, Arizona. I very much enjoy your program, but in the March 10th program, you were talking about chemicals from asteroids. And even given our accent differences, you murdered Osiris-Rex, long O, which is a product of the astronomy department at the University of Arizona, Tucson. So, yay us. Thanks for everything you do.
Thank you, Mary Jo. Thank you for the correction. You know, when we first started talking about it, I did say Osiris-Rex, and I self-corrected because Fred said it another way, and I thought, well, the astute Fred Watson would be getting this right, and I've got it wrong. So I'm putting it on you, Fred.
Look,
I can't even remember what we were calling it. Osiris?
No, I can't either. But yes, thank you very much, Mary Jo. It's very well taken. And actually, we should put out a hello to everybody that if we are mispronouncing words, please let us know, because we'd very much like to know, and especially when we've got such an international audience. And may I just add a comment as well? We've had a fairly United States emphasis on our questions on this episode, but that doesn't mean that we're not listening to other ones, and hopefully soon we'll be able to cover questions from Sweden. Orca's sent us more questions from other countries in Europe and everywhere else where people listen to the Space Nuts podcast. We're not just focusing on the US audience. We love everybody. So thank you for all your questions and keep them coming.
Indeed, yes. Thank you. And if you'd like to send us questions, do it on our website, spacenutspodcast.com. You can send it as a text question, or you can record it if you've got a device with a microphone through the AMA tab on our page. And yeah, it's as easy as pressing the button and saying, "Hi, I'm Fred from Sydney and I want to know everything." So it's as simple as that. But yes, thank you very much to everyone who contributed today, even the half Australian Michael from Oregon. Nice to hear from you. And thank you, Fred, as always. Great to catch up. We'll catch you again next week.
That sounds good. Thanks, Andrew. I'll look forward to that, and all the best. Take care. Watch out for those mice.
And watch out for those floodwaters. Yes, indeed. And from me, Andrew Dunkley, thank you for joining us yet again on another episode of the Space Nuts podcast. We'll see you again real soon. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.